Hello and welcome to Math 8, Unit 1B, Lesson 8. Today's objective is scholars will use multiple transformations to create congruent and similar figures. So, what is the difference between congruent and similar figures? So, congruent figures are exactly the same in shape and size. Congruent figures are created using translation, rotation, and reflection. Similar figures are the same shape, but different sizes. They're created using dilation. Think about it. When we dilated, we changed the size, but the shape stayed the same. So what are multiple transformations? It might be maybe reflecting and then translating, rotating, then reflecting, translating, then dilating, reflecting, then rotating, then translating, or any combination of transformations. So let's look at this problem. It is about an alumni center. So, a university has an alumni center. You can see their alumni center right here. They have an alumni center. They're considering relocating it to one of the alternative locations that are shown. You see I have alternative location A right here, alternative location B here. Each unit on the grid represents 10 meters. So then we have a question. Can the university move the alumni center to location A without changing the size or the shape of the building? So that's what we're being asked first. Could they move it? Basically, could they pick up the alumni center and move it to the new location without changing anything about it? So let's look at that. I can see where the corners of this are. I need to find out if these are the same shape. So I can see this is 4 units. This is 4 units. This side is 6 units, 2 units, 2 units, 2 units. Okay, now let's look at location A. Location A, this side is 3 units. This side is 4 units. This side is 5 units. 2 units, 2 units, 2 units. So do those match? So no, they can't, because the figures are not the same. So those figures are not the same. So now here's the next question. Can the university move it to location B without changing the size or the shape of the building? So we're going to do the same thing. We are going to look at the size of the different sides and determine if they match. So here again I have 4 units, 4 unit. Ooh, wow, that was not pretty. 4 units. So this is 4, 4, 6, 2, 2, 2. Here I have 2, 2, 2, 6, 4, and 4. So can they move it there? Well, the answer is yes. The figures are the same. The figures are congruent. And I can tell that because I know all my sides match. And all the angles are all 90-degree angles. Okay, so now we're being asked to list the vertices, and those are just the corners, of another location for the alumni center. So we're going to describe a sequence that contains at least one rotation, one reflection, and a translation, and show the congruence between the figures. So we need to talk about how we're getting from one point to another. So the first thing we do is I'm going to say, because I just want to make this easy, I'm going to move this figure over here into this third quadrant. Just because nothing else is there, it makes my life just a little bit easier. I'm thinking I'm going to do a rotation over to here. So we're going to rotate 90 degrees counterclockwise. Then I want to reflect it over to here. So then reflect over the x-axis. And then I'm going to translate down 1 unit. Nice, simple thing. Okay, so let me real quick erase some of this. I don't want these arrows here right now. Okay, put my highlight back in there though. Okay, so let's look at how we're going to do this. So we're going to rotate and then reflect and then translate. But I need to get those points. So let's start with getting those points. So, sorry, didn't mean to make that quite that big. Okay, so let's start with naming all these points to make our lives a little easier. So the first point I have right here is the point 2, 2. This point then is 6, 2. This point is 6, 6. This point is 4, 6. I need to name all these points. This point is 4, 8. And this point is 2, 8. Okay, so those are my points. Pull this back out a little bit. First thing I'm going to do is I'm going to rotate it. So I'm going to do this one in blue. I'm going to rotate it 90 degrees counterclockwise. So 2, 2 becomes negative 2, 2. 6, 2 becomes negative 2, 6. 6, 6 becomes negative 6, negative 6. 6, 4 becomes negative 6, 4. 4, 8 becomes negative 8, 4. And that point goes there. So here is my rotation, 90 degrees, counterclockwise. Okay, so when I name these points, that'll help me again. So again, this is negative 2, 2. This is negative 2, 6. This is negative 6, 6. This is negative 6, 4. This is negative 8, 2. No. Negative 8, 4. Sorry. Negative 8, 4. And then this last one is negative 8, 2. Okay, now I want to reflect it. So my reflection, I'm going to do this one in green. So reflecting across my x-axis. Okay, so when I reflect, I'm going to simply go the same distance apart. So this point here, negative 2, 2 becomes negative 2, negative 2. Negative 2, 6 becomes negative 2, negative 6. And then we have the point negative 6, negative 6. So there's all of my points of my reflection. And then finally, I am going to translate every single point down 1. So this point goes here, this point goes here, point goes here, this point goes here, this point goes here, and this point goes here. So these are actually the only points that I have to name. So let's go ahead and name these points. This is our reflection. So I'm going to go back through, like this was our rotation. This was our reflection. And then red is our translation. So now I have the point negative 2, negative 3. Ooh, that didn't look very well like a 3. Then I have the point negative 2, negative 7. Then I have the point negative 6, negative 7. This point here is negative 6, negative 5. This point over here is negative 8, negative 5. And this last point is negative 8, negative 3. And there I've created a new figure that is congruent, that was simply rotated 90 degrees. That was, again, that was the blue. Rotated 90 degrees. And then reflected across the x-axis. And then translated down. Okay. So finally, let's look at describe a combination of two transformations that would move figure A, B, C, D to figure A prime, B prime, C prime, D prime. So I'm trying to go from this figure to this figure. Then I want you to describe a combination of two transformations that would go the other direction. Okay, well, let's think about this. To go from my A, B, C, D, E to A prime, B prime, C prime, D prime, E prime, I could, let's see, I could reflect over the x-axis. That would move it down here. And then I could reflect over y. That's one way to get from my original to my new one. So let's go to the other way. To go the other direction, I could reflect across y and then translate up. I would just have to translate up 1, 2, 3, 4 units. And there's many other ways you can get from one to the other. So try to come up with at least one other way on your own. Okay, go ahead and complete your working class, and I will see you then.